Hello everyone, this video is about error propagation in product and division of two physical quantity. So after this video you should be able to derive and apply the formula for error propagation. Before we derive the formula, we should know some basic math. So as we all know, we write the corrected form of a measurement in this way. So a plus minus delta a. So a is the true value and delta a is the mean absolute error. So out here you can see example 10 plus minus 0.2 meter, and out here you can see the error is always smaller than the true value. And suppose you square a number which is greater than 1, then you will get the number which is more than that number. So out here 3 square is 9 and 9 is greater than 3. But if you square a number which is a decimal number and which is less than 1, then you will get a number which is less than itself. So out here you can see the square is 0.09 and number is 0.3. So square is less than the number, just opposite to this case. So here if you increase the power, the number become further small. You can see 0.3 square is 0.09, and if you take 0.3 to the power 4, you will get 0.0081, which is less than 0.09. So more the power of a decimal number which is less than 1, smaller the value we get. So, and if you multiply two numbers which is less than 1, then their product will be less than either of the number. So 0.06 is less than 0.2 or 0.3. And if you add 10 to 100, so you will get 110. But when we consider a very big number, and if you add a small number, it won't affect. So you can write this big number plus 10 is nearly equal to this big number. Example is adding a 1 mug of water to the ocean won't affect the ocean. So same thing happens out here. So if you add and subtract small number from very big number, you get nearly that number. And we know this formula, a plus b whole square is a square plus 2ab plus b square, but we don't know the formula for this. So to get this formula, we make use of binomial theorem. So using this binomial theorem, you can find the any power of a plus b. Out here we have used 2 factorial, 3 factorial, n factorial, and 2 factorial means 2 into 1, and 3 factorial means 3 into 2 into 1. So you have to multiply the number in backward direction till you get 1. So 4 is 4 into 3 into 2 into 1. So let's see some examples. So if you take x plus y cube, then you see first number is the first number to the power which we are giving. So in next step you can see this power is decreasing. From 3 it has become 2, and it will become 1, and it will become 0. And if you see y, so power of y is 0 out here, 1 out here, 2 out here, 3 out here. So power of one of the variable decreases and power of another variable increases when you go from left to right. Similarly out here you can see it is starting from 7, 6, 5, it is going to 0, and for y it is starting from 0, 1, 2, 3. So this is how a binomial theorem works. If you take a to be 1 and b to be x, then the formula will look like this. So out here you can see power of x is increasing. Any power of 1 is 1, so we are not writing the power to the 1, only the power of x is out here is 0, out here is 1, 2, 3, so it will go till n. Suppose this x is less than 1, so let's take x is 0.1. so for first time out here you can write x is equal to 0.1, and when you take x square out here it will become 0.01, out here it will become 0.001. so value will decrease when you go towards the right, but these values are very small. After x square the value becomes very small, so we can neglect this number. So higher power of x can be neglected, so x to the power larger number is nearly equal to 0. So this 0.01 is as compared to 0.1 is very small, so I can take this to be 0. X square, x cube, x to the power n, we can neglect them because their value is very small. So I'm just left with 1 plus nx. So for small value of x, 1 plus x to the power n is 1 plus nx. So this we are going to use in our derivation. And this also 0.2 into 0.3 is 0.6, which is less than 1. And if you have a small decimal number and we have large power, for that also we can write 0, and error is very small as compared to the true value. So now let's start the derivation. So error in product of two physical quantity. So we are taking a and b, and the error is delta a and delta b. So we are taking the product of two variables, a into b is equal to c. So now error in c can be written as c plus minus delta c is equal to a plus minus delta a into b plus minus delta b. So now I'll multiply this. So this a into b is ab, and a into delta b is a delta b plus minus delta a into b is, so I'll write b first and delta a afterwards. So this is b into delta a. So similarly delta a into delta b, and now I'll divide both sides by ab. So now I'll separate all the numbers. So out here ab can be written as c because a into b is c. So out here is also a, b is c, and out here I am cancelling a and a. So I cannot cancel delta b and b because delta b is different thing and b is different thing. Out here I am cancelling b and b, so I am left with 1. So c also get cancelled. So 1 plus minus delta c by c. So this also becomes 1. So delta b by b, delta a by a, delta b by ab. So I can cancel this 1 also. So now if you take this term, as we have already said, error is very small as compared to the true value. So when you multiply this two small number, you will get very small number, and when you multiply this true value of a and b, you will get large number, and if you divide very small number by large number, you will get a number which is nearly 0. So out here you can see the example. So suppose delta a is 0.1, delta b is 0.2, and a is 20, b is 50. So you will get this number, and when you divide this, you will get 0.0002, and which we can neglect, and so I'll write 0 for this. I'll get delta b by b plus delta a by a. So now I'll cancel this plus minus, and delta c by c is equal to delta b by b plus delta a by a. So maximum fractional error in the product of two physical quantity is sum of fractional error in the two quantity. So the relative error or fractional error will get added in the product of two physical quantity. So similarly, let's see error in division of two physical quantity. So same thing I am taking, but only c is equal to a by b. So now I'll put the values. C plus minus delta c is a plus minus delta a plus b plus minus delta b. So now I'll take a common from numerator and b from denominator. So when you take a, you will get 1 out here, and if you don't have a out here, you have to write 1a in the denominator. So this will become delta a by a. So similarly b 1 plus delta b by b. So when you multiply this back, you will get this value. So now I am taking this to the numerator and making the power minus 1. Now if you see this value, this is error by the true value, and error is always small and true value is large. So if you divide a small number by large number, you get the value which is less than 1. So if x is less than 1, then 1 plus minus x to the power n is 1 plus minus nx. So this we get from binomial theorem, so which we have discussed in the beginning of the video. So for this term I can write 1 plus minus delta b by b. So when you multiply this n, that is minus 1 out here, so you will get plus minus only. So this 1 will become minus, 1 will become plus. So now putting values, delta c by c is a by b into this and to this. So now I'll open this bracket and multiply these two terms. So you'll get 1 into delta b by b, delta a by a into delta a delta b by ab. So a by b is c, we have already assumed in the beginning. So now I'll divide both side by c. So when you divide both side by c, this c and this c will get cancelled. So I'll separate these two c's now. So when you separate this, you can cancel. So you will get 1 plus minus delta c by c and this term. And this 1 and this 1 I can subtract. And you are left with delta c by c is equal to plus minus delta b by b plus minus delta a by a plus minus delta a delta b by ab. So now this term, last term, is a very small number divided by a large number. So example, so you can write 0 for this. So in your notes you don't need to write this. I'm just showing you the example how do we get the small number while dividing small number by large number. So I'm neglecting this term because its value is very small as compared to other values. So now I'll take plus minus common and I'll cancel this. So you're left with delta c by c is equal to delta b by b plus delta a by a. So maximum fractional or relative error in the division of two physical quantity is equal to sum of fractional errors of individual quantity. So in both division and multiplication, the fractional error get added. We'll solve some questions on this error propagation in multiplication and division in next video.